So, hello guys, let's check the new exercise. This exercise, like previous ones, is related to trees. So we continue to improve our knowledge, how we can use this structure and how to solve exercise related to this structure. So let's check the condition. And condition says that we need to create a method that will extract the node value of a binary tree level by level, such that the values are grouped by each horizontal level from top to bottom. Within each level, the values are ordered from the left to right. So we will need to create a method level order, where we will set an argument which will be root of the tree which we want to traverse, and we need to return a list of lists containing integers of each level, so containing values for each level. And in the previous exercises which we resolved in previous videos, we actually used this type of traversing, depth first search, where we started from the root, then we go to the left and then to the right. In that exercise, we are asked to traverse our tree using breadth first search, and the idea is that we will start from the beginning, then we will start from the second level, also from the first element and the second element, then we will go down again, we will start from this element, then this and this. So we go through our tree from top to bottom and left to right. I hope this is clear. And now let's go to our exercise. So let's try to implement our method. So let's start. So our method will be public. And like we were asked in our exercise, we will need to return a list of lists. Every list inside our list will contain elements in his level. So let's do it. List of lists. And here we will have integer. And let's call our method like level order. And we will have here an argument. When we will call this method, we will need to pass root of our tree which we want to traverse. So here let's write something like this: tree node and root. And now let's write the logic. So first of all, let's create our result. Our result will be a list of lists, which will contain an integer in our case, because the value of our node is an int. And let's call this list of lists like result, which is equal to new array list, and that's it. So we initialized our list. Now let's put a condition that if root, so initial node is equal to null, if root is equal to null, then in that case we can return an empty list. So our result, return the result. If you have watched previous videos, you remember that there we have used recursion. In that case, we will not use recursion, but we will use a queue in order to solve that task. And the idea is that this queue will contain elements. So in one iteration, this queue will contain elements from one specific level. So for first iteration, this queue will contain elements from the first level. In second iteration, it will contain elements from the second level, and so on. So for that, first of all, let's create this queue. It will contain nodes, our nodes, 3 nodes, and let's call it queue, let's call it queue which is equal to new linked list. And now let's, so the first element from which we will start, it will be the first level, so our root node which we will pass in this method. So let's add this node inside our queue. Add root. Perfect. And now we will need to create a loop, yeah, because we will need to make some iterations. How much iteration initially we don't know, and we will need to put a condition when to stop these iterations, because we don't want them to be infinite. So let's use here while, and inside this while let's put a condition that when this queue will be empty, then in that case it means that we have traversed all levels and now our queue is empty, so we don't have any more elements to process, so we can stop our loop. So we will execute logic from inside till that moment while our queue is not empty. And now here inside this loop we will process elements from this queue, but the problem is that during this processing in this queue we also will add elements from the next levels. You'll see how it will happen, and somehow we'll need a tracker or a logic to know how much elements we need to process from this queue. For example, if we need to process the second level where we have only 2 elements but our queue has, let's say, 5 elements, we need to know that first 2 elements we just need to process them. The rest we will not process in that iteration. So for that we just need to know the initial size of our queue. For example, yeah, initially we will place just elements, just nodes, I mean, in this queue just from their level. Yeah, so initially it will contain only elements from the current level. So we can do something like this: a level size, and it will be equal to queue size. Yeah, because like I already mentioned, we only will have initially elements from each level, but during the process we will also add some elements from the next levels. But initially it will be only elements from that specific level. So, and how much elements will be there we can find out by using size, by getting size of the queue. And also here let's create a list of integers. Here we will put our elements from the current level. So current level equal to array list. Perfect. And now we need to know how much elements from the current level we need to process. For that we need to use for, yes, because it will be we will have a repeating logic. We will repeat some logic for all elements from the current level, and let's declare here int I is equal to 0, and we will process only elements from the current level, which is equal to level size, and I++. So here inside this block of code we will process only elements from the current level, and if during this processing we will add some additional elements from the next element, we will process them on the next iteration of a while, but not here inside this for. So now we can get step-by-step elements from the first level. So let's create a variable where we'll store this node, current node, and let's pull this element from the queue. Pull is a method which extracts and deletes an element from the queue. So we will get the first element from the queue, which we put inside this queue, and it will be deleted. So queue is working by principle first in, first out. Yeah, so the first element which we will put in this queue will be extracted. And now let's add this element inside our current current level. So let's add this element, current not. Yeah, integer. Actually, here we need to add the value on this node. Yeah, perfect. And you can imagine, so for example, we start from the first node. This level is first level, and this level has only one node, the first node. And we put this first node inside our current level list, and it will contain only this value. Yeah. After that, let's check if current node, first node, current node. Okay, should do this inside the for. If current node has left subtree, so if it's not equal to null, then let's add all elements from the left subtree inside the queue. Current not left, and if current node has right subtree, so if it's not equal to null, also let's put these elements inside our queue. Yeah, and then let's take this result, current level. It will contain, it's a list of integer. Initially it will contain the first node from the first level, and let's add this list inside our result, which is a list of lists, if you remember, current level. Yeah, and in the end we just will need to return our result, and that's it. That's the solution. So the idea is that after when we will add the left nodes from the current node and the right nodes from the current node, we will start a new iteration. Yeah, here, well, because our queue is not empty, because we have put additional elements inside this queue. So we will start a new iteration. We will recalculate the level size, and it will be equal to how much nodes we have on the second level. And again, inside this for, we will put these elements from the second level inside a new list, yeah, inside this current level, and then it will be the second value inside our result, which is a list of lists, and that's it. And this we will repeat until the moment we will not reach the end of our tree. And the last thing which I want to show you is the complexity. So the time complexity for that solution is O(n), and the space complexity is also O(n). So I hope this video was helpful for you, and we will see in the next one. Bye.